Alright guys, so welcome to part 2. So just now we learned how to assign oxidation numbers. So now we can continue to learn how to actually use the ion electron method. So ion electron method we will use when we are balancing our redox reaction. Okay. The thing with redox reaction is that sometimes it may occur in acidic or even basic solutions. So we will follow these steps systematically, betul-betul, so that the equations become easier to balance. Okay, so the first 5 steps will be for reactions in acidic solution. Okay, so maksudnya awak memang akan kena buat these 5 steps. Okay, sampai sini. So let's say kalau itu adalah in acidic solution, you will stop at step 5 lah. But if it is in basic solution, you will have an additional step which is step 6. Okay, so maksudnya awak sambung lah to step 6. Okay, so we will do these steps one by one so that you won't be overwhelmed. Okay, but the first thing that I want to point out is that yang tadi tu awak belajar untuk assign oxidation number, it is important because the first step in balancing a redox reaction is you have to know which one is your reduction reaction and which one is your oxidation reaction. So if you know that your oxidation state increase, okay, itu adalah oxidation. When your oxidation state decrease, that will be your reduction reaction. So from there, you already know how to do step 1 lah. Okay, so then let's look at our example. So we will carry these steps, we will apply these steps onto this example. Okay, so let's say if this is an inacidic solution, right? So bismillah. So step 1, you must first divide the equation into 2 half reactions. So reduction dengan oxidation. So what you're going to do first is you're going to copy back this chemical equation. Okay, so now copy balik. Then what you're going to do next is you are going to draw arrows. So this reactant akan jadi which product after. So awak boleh tengok awak ada manganese here. So that means that dia akan berubah jadi inilah. And then this one C2O4 minus will become carbon dioxide. Okay, so what happens between this arrow? I mean, what happens between, what happens here? What happens here? Awak akan alami redox reaction lah. So now how are we going to know whether who undergoes reduction, who undergoes oxidation? How did I know? How did I know here? Okay, what you're going to do is you are going to assign the oxidation state of manganese and carbon. So what I did here on the right, okay, for MnO4 minus, I need to find the oxidation state of manganese. Okay, so carilah macam yang tadi saya ajar awak, and you got plus 7. So you know that MnO4 minus here, your manganese has plus 7 oxidation state. Okay, and then it will form Mn2 plus, so the oxidation state is plus 2. So from here you know that the oxidation state decreased. Okay, so if it decreased, that means that MnO4 minus has undergone reduction. So that's why saya letak reduction kat sini. And if you count the oxidation state for carbon in C2O4 minus, you will find that it is plus 3. And in CO2, carbon dioxide, your carbon is plus 4. Okay, so you can see that the oxidation state increased. So that means that C2O4 minus has undergone oxidation. Dia dah lose electron. Okay, okay, so that's the first step. The second step we need to do is to balance each of the half reaction. How are we going to balance? So, dia ada sub-step, step yang lebih kecil, okay? 1, 2, 3. So, the first one is to balance the elements other than oxygen and hydrogen. So, who are they? who are these elements in these half reactions. So we will first look at C2O4 minus and CO2. So selain oksigen dengan hidrogen, bukan yang ni. So you can see you have carbon kan. So carbon tu, on your left you have 2 carbons and on your right you have 1 carbon. So in order to balance, you will put 2 here. Betul tak? Okay, betul Okay. So next, your reduction half equation pula. Tengok manganese tu. Okay. So manganese sini ada 1. Manganese sini ada 1 juga. Okay. So that means you don't need to balance lah manganese. Okay. So what will we get? We will get this. Okay. You balance carbon and manganese. So sekarang kat sini ada 2. Okay. So the next small step is for you to balance the oxygen atom by adding H2O. So maksudnya kalau awak ada 1 oxygen atom, you will add H2O in your chemical equation. I mean your half reaction equation. Okay. If you have hydrogen atom, you will add H+. Okay. So let's say if you already added H2O, that means you will have to add H+, kan? Sebab dalam H2O ada hydrogen. Betul? Okay, how does that look like? Let's look. Okay, dari sini. Tadi kata kita nak okay, for extra oxygen, you will balance with adding H2O. So, kita tengok dululah dekat sini. Okay, oxygen ada 4. Kat sini oxygen ada berapa? 4 juga. So, kena ke add water here in your oxidation half reaction? Kena tak? Tak payahlah Okay. So, here in reduction, awak tengok oxygen ada 4. Kat sini ada tak oxygen? Tak ada kan? Tak ada kan? Mana? So, that means you have to add water. Okay. So, that means you will add water where? Since you have 4 oxygens here, you will add 4 molecules of water on your right. Okay, the opposite side. So sekarang, on your right, you have 4 oxygen. Your left one, you have 4 oxygen. Okay. Okay, after that, you must add H+ for your extra hydrogen atoms. Okay. Kalau awak tengok kat atas ni, ada tak hydrogen? Okay, tak ada. So bawah ni, ada tak hydrogen? Ada tak? Ada kan? Dekat dalam water. Sebab awak dah add water. So sekarang awak ada berapa hydrogen? You have 4 times 2. It will be 8 hydrogen. So that means that you have to add 8 H+. Okay. So on your right you have 8 hydrogens. That means that you have to add 8 H+ on your left. Okay. So tambahlah kat sini. Okay. So bila awak buat macam tu, you will get this. Okay. You will get this equation. So sekarang dah ada plus 4H2O dengan plus 8H+. Okay. So do the step one by one. Okay. Next, you want to balance the charge of your half reactions. Okay. Ni, the small step. Balance the charge by adding electrons to the side with the greater overall charge. The more positive side. So, siapa side, kanan atau kiri yang lebih positif, awak kena add electrons dekat situ. Okay, supaya charge kiri dengan kanan sama. Okay, so let's look. Okay, since kita dah ada kita punya this half equations, okay. So kita akan keluarkan dia punya charge, okay. How? So let's start here. C2O4 minus, berapa charge dia? Minus 2. Okay. And then your CO2, charge dia apa? Ada charge tak? Tak ada kat sini tak ada apa-apa kan. So dia 0 charge, okay. So for your half reaction, this half reaction, mana lebih positif? Kiri ke kanan? So kat sini lebih positif. So what are we going to do? We are going to add electrons here, okay. Berapa electron should we add? We will add 2 electrons, okay? We will add 2 electrons in order to have the same charge on both sides. So kat sini ada minus 2. So sekarang bila awak add 2 electrons kat sini jadi minus 2 jugalah. Okay? Right. So untuk yang bottom ni, your reduction half equation, MnO4 minus, the charge will be minus 1. Okay, and then you have 8H plus, that will be berapa? Proton plus 8 lah. Okay, so maksudnya overall charge on your left will be berapa? Minus 1 plus 8, it will be plus 7. Okay, so on your right pula, you have Mn2 plus. Okay, Mn2 plus, maksudnya ini plus 2. And then you have 4 water molecule. Your water molecule is neutral, so it will be 0. So the overall charge will be plus 2. Okay. So now we look. Which side is more positive? Left or right? Left. Okay. So here we have plus 7. Lebih positive. So, how many electrons should we add on the left side so that awak punya charge will become plus 2 sama dengan yang kanan ni? You will add berapa? 5 electrons, okay? So bila awak add 5 electrons plus 7 minus 5, it will be plus 2, okay? So that is how you balance the charge of your equations. Okay, so here saya dah plus 5 electrons. On here, I plus 2 electrons. Alright? Okay, so that is balancing. Okay, the third step is for you to multiply each half reaction by an integer so that the number of electron lost in one half reaction equals the number of electrons gained in the other. Apa ke bendanya itu? What does that mean? Okay, so that means that you need to get the same number of electrons on each half reaction so that you can cancel out the number of electrons later. Okay, so maksudnya kalau tadi, okay, saya just salin balik my equation and I can see that I have 2 electrons here. Okay, on my reduction half equation, I have 5 electrons. So, untuk samakan, okay, to equate the number of electrons on oxidation and reduction half equation, I will times it with 5 on the first one so that I can get 10 electrons here. But don't forget, okay, this bracket means that you will multiply with each of the stoichiometry coefficient. Okay, untuk carbon dioxide, you will times with 2, 5 times 2. And for C2O4 2 minus, you will times with 5 here kat sini. So, ini akan jadi 5, ini akan jadi 10, ini akan jadi 10 lah. Okay, so bawah pun sama. Okay, untuk dapat 10 electrons, you will times 2. Okay, so kat sini pun times 2 akan jadi 8, times 2 jadi 2, times 2 jadi 16, times 2 jadi 2 lah. Okay, kat sini dapat 10. So, when the number of electrons are the same, later you can cancel out. In the fourth step, where you will add the two half equations and simplify where possible by cancelling the species appearing on both sides of the equation. So, maksudnya mana species yang sama, kita akan cancel out. Okay, so, tadi kita dah kali kan? Okay, so kita dapat ini. Kita dapat 10 electrons. Okay, what I did was, mak kau terbalik. Sorry. Okay, what I did was, I cancelled out. Okay, dah dapat 10 electrons ni, I will cancel them out. Okay, since they are on opposite sides. Okay, ini on the right, ini on the left, so bolehlah cancel out je. Okay, so when I add all these together, I will just bring this down. Bring this down, bring this down. This one bring down. Ini dah cancel out tadi dengan yang ni. Ini bring this down, bring this down, bring this down. Okay, so simple addition. Okay, alright. So the next step, which is step 5, is to check the equation to make sure that there are same number of atoms of each element and the same total charge on both sides. So maksudnya you have to make sure that the number of atoms and the total charge will be the same for reactants and products. So yang number of atoms tu awak boleh lah kira sendiri, check sendiri. Okay, so the total charge macam mana nak kira? It is this way. Okay, so untuk charge of reactant, you will times, okay, your stoichiometry coefficient with the charge. 5 times minus 2, you get this, plus 2 times minus 1, you will get this, plus 16 times plus 1, you will get this. Okay, so add them all together and you will get plus 4 for the total charge of reactants. So the same thing you're gonna do for the product side. Okay, you will times 10 with berapa? Ada charge tak kat sini? Tak ada kan? So dia adalah 0 lah. 10 times 0 plus 2 times plus 2, okay, plus 8 times 0. Okay, so the total charge will be plus 4. Alright, so that's how you know that you have the same number of atoms and same total charge on both sides. Alright, so if this is in acidic solution, okay, if the question mentioned that this reaction is carried out in the acidic solution, then you will stop right there. Your answer is this one lah. This will be your answer lah, your balanced chemical equation in acidic solution. But let's say if they kata it is in basic solution, so you already got to step 5, you will have to continue to step 6 lah. So for step 6, okay, for basic solution, you will add the same number of OH minus as H plus on both sides of the equation. Okay, so nanti OH minus and H plus on your same side, okay, let's say on your left side, on the reactant side, will combine to form H2O. Okay, OH minus plus H plus akan dapat H2O, satu H2O molecule. Okay, so maksudnya kita kena tengok apa ni? Kita kena tengok lah, kita ada berapa H plus in our equation, redox equation. Okay, so from here, okay, the number of H plus ions is 16. Okay, so that means that you have to add 16 OH minus on your left side and 16 OH minus on your right side as well. Okay, so let's do that. Okay, look there bro. Okay, if you look here, I already added. Okay, since we have 16 H plus, I will add 16 OH minus on my left and 16 OH minus on my right. Okay, what will we do next? Okay, tadi kita cakap yang the H plus and OH minus on the same side, okay, same side, will form water. So that means that these 16 H plus and 16 OH minus will form 16 H2O molecules lah. Okay, so write that down. Awak dah dapat your 16 H2O molecule. Okay, so now that we have 16 water molecules here and 8 water molecules here, what can we do? We can cancel out. Okay, so kat sini ada 16. Okay, kat sini ada 16. What will happen is that you will minus with 8 of the water molecules that is in your product. Okay, so 16 minus 8, you will get 8 water molecules here. Kat sini dah kena buang. Okay, so 16 minus 8, 8 lah kan. So tinggal 8 water molecules on your left hand side. Kat sini akan buang. Okay, so that's how we get our final chemical equation. okay, with 8 water molecules and 16 OH minus. Okay, so okay, apa beza dia bila awak punya chemical reaction, your redox reaction is in acidic solution dengan basic solution. Okay, you can see how many H plus ions and how many OH minus ions, hydroxide ions, are present in your balanced chemical equation lah. Okay, so let's say kan tadi yang kita stop kat sini, ini adalah kalau awak punya balanced equation in acidic solution. You can see that you have 16 H plus ions. Tak ada pun OH minus, tak ada hydroxide ion. You have 16 protons here. So maksudnya ini adalah dalam acidic solution lah. Okay. In basic solution, you will find hydroxide ions. Okay. So you can see that you don't have any more H plus. Okay. It is gone. It has become water. Okay. But you have hydroxide ions present. Okay. So that's just extra info that I want to tell you. Okay. So that is how you balance your redox reaction. Okay. So basically for example 1 tadi, I already did this example. Okay. Which is quite long. So now I want you to do this example on your own. Okay. Follow the steps one by one, step by step. Okay. And then do this example as well. Okay. Alright. And then do these exercises pula. Oh my god, miss, you're crazy. But it's okay. This is practice and it will be beneficial for you. Okay. So you can do this in your study groups. Okay. Discuss among each other and we can check our answers in our class nanti. Okay. Alright. Thank you.